Hello everyone and happy Friday. Welcome to the fourth edition of our Cardano Developers Office Hours. I'm Lisa. I'm going to be your host for today's session. So just a quick few announcements before we start. So on the 2nd of December, you have launched the 2025 Holiday Season Challenge. That's going to be running until the 16th of January, and you're inviting all the developers to contribute to a great set of 20 common blockchain use cases. So that covers the on-chain and off-chain scenarios. Some of the use cases have already been implemented. However, you can always submit a new implementation using your preferred tools or framework, or simply try a new use case. So the price for that, for the first place, it's $1,000. And then for the second place is going to be a Cardano Time-on NFT. So you have the option to keep it in your wallet or simply like burn it and then get access to your beautiful diamond. It's entirely up to you. So if holiday season is the time that you enjoy to do something productive that you don't have time to do in your routine, that might be a great opportunity for you. So another reminder is that our Cardano Academy is running, they are giving away 100% discount voucher for the CBCA exam. Unfortunately, that's going to end soon. So if you would like to get certified and don't spend any money on that, that is a great opportunity for that. And then let's dive into the main session because we are very excited to have George, Ilia, and Peter here with us. They are from the Hydrozoa team, and they're going to give us an overview on the Cardano's lightweight state channel framework. So without further ado, George, the stage is yours.
Thank you there, Lisa. Yeah, indeed. So today I'd like to talk about Hydrozoa, which is a lightweight state channel protocol inspired by Hydra, but applying some of the best practices that we have learned in the last 3 or 4 years of Cardano DApp development. So yeah, today's outline is first I'll do an introduction to Hydrozoa, then we'll talk about how Hydrozoa's consensus works, and then finally how Hydrozoa interacts with Cardano. Hydrozoa generates some. There's some activity on L2, and somehow periodically we need to translate that into things that happen on L1, right? Some like sequences of transactions essentially that need to happen on L1 to keep things in sync. So first, let's do an introduction of Hydrozoa. So at its core, both Hydra and Hydrozoa and most state channel protocols are essentially glorified multi-sig wallets. You could think of them. Right? So you have a group of people that want to manage their funds and information via a virtual L2 ledger with rules that they collectively enforce, right? So this means that the group holds the funds collectively on L1, but in the L2 ledger, those funds can freely be allocated to any group, individual, or script, right? And so if we look at L1, one of the innovations of Hydrozoa is that we said, well, okay, when everything is working fine and all the peers are responsive to each other, the L1 state doesn't need to be any more complicated than just holding it in a native script, i.e. a multi-signature script. Because if the peers are capable of agreeing with each other, then they should be able to just, whenever they need to change something, they need to bring in funds or they need to send out funds from what's being controlled by the head, their signatures collectively are all that's needed. Right? You don't actually need any smart contract interactions. You can just have a multi-signature transaction that does what you want to do, right? And so then the essence of the consensus protocol, when all the peers are responsive to each other, is just a way to coordinate, the group's decision on what's the next thing that we want to multi-sign, right? And then gathering all those signatures. That's at its essence. That's what Hydra and Hydrozoa are doing in their L2 consensus. However, we can't rely on all the peers being responsive to each other in all circumstances, right? Peers may drop off, or some peers may decide to flip the table or act maliciously or so on, right? And in those situations, we need to have a backup plan, right? We need to be able to fall back to what I call a rule-based regime, right? where the Plutus scripts kick in, and they ensure that everybody is able to recover their funds out of the head, without being blocked by any other person, right? So this is why we have two regimes. We have the multi-sig regime, right, which is when everything is sunny and bright, everybody's cooperating, right? In which case, you don't need to have any fancy scripts or mechanisms. You just need to have, an L2 protocol that coordinates, what people want to do and just gathers the signatures from them. And as a backup plan, we are able to fall back to a rule-based regime where the Plutus scripts take over, and they ensure that everybody gets a chance to say, okay, this is the last thing that we all had agreed to back on L2 when we were all responsive to each other. And based on that, I would like to withdraw my funds, right? Based on that L2 state. So we have these two regimes. Correspondingly, in the two regimes, there's different types of interactions with L1. So in the multi-sig regime, right, and optimistically, like if all the peers remain responsive to each other for the entire life cycle of the head, we can just stay entirely in this regime from beginning to end, and we never need to go into the rule-based regime. And so the way it works on Cardano L1 is we initialize the head with a single L1 transaction. And this transaction just puts some funds into the head's treasury, right? And initializes an L2 ledger state that has some initial UTXOs on L2, which will then be spendable by the peers via L2 transactions, right? And we can deposit more funds into the head, right? So we have deposit transactions which create UTXOs, and those UTXOs need to sit for a while on L2 just so we know that they're settled, and then we will attempt to absorb them into the head's treasury via settlement transactions. I see a question from Michel. Yeah, initiation indeed can put not just ADA, but also any multi-asset into the head's treasury, right? So we don't really care. Same thing with deposits. The deposit UTXOs can contain, ADA or any multi-assets, right? So I'll dive into these things in more detail, but for now, let's just say, all right, so you have deposit transactions that create deposits that will sit for a while, and then they can be absorbed into the head via the settlement transactions, right? We also have refund transactions, which are just there to assure that if the deposits created by the deposit transactions are not absorbed by the head via settlement transaction, the depositors, like the users, can recover their funds via these post-dated refund transactions that are multi-signed, so that we make sure that deposited funds are never stranded in the head. There's always a way for the user to recover their funds, either via these refund transactions, in case the deposits were not absorbed into the head via settlement, or if they haven't absorbed into the settlement, then the users can withdraw funds directly, from L2, and then those withdrawals are paid out by settlement or finalization transactions, or if consensus breaks down, we can go to the rule-based regime, and then after kind of the dispute resolution process and stuff, people are able to unilaterally withdraw their funds from the head without requiring the signature of everybody else. So this, at a high-level view, this is a high-level view of how like the different types of L1 transactions with which Hydrozoa interacts with Cardano. So let's take a look at the L2 ledger. So if we zoom out, the L2 ledger is basically a timeline of events of different types. So these yellow ones, we call these genesis events. And this is where we add UTXOs to the L2 ledger based on the deposits that we've absorbed on the L1, right? Because obviously, if we're absorbing deposits on L1, we just added more funds to the treasury. So on L2, we need to create some UTXOs essentially out of nowhere, right? That correspond to those deposits that we've absorbed. Then we have these green squares. These are simple L2 transactions, right? So simple L2 transactions, what they do is they spend some L2 UTXOs and they produce some L2 UTXOs. And of course, they can also reference some L2 UTXOs. And the rules for these L2 transactions are exactly the same, essentially, as on Cardano mainnet, right? With small modifications like, we don't need any of the legacy stuff. So all of our UTXOs are Babbage, all of our Plutus scripts start from Plutus v3. We don't need to support any of the legacy stuff because we don't actually have any legacy state the way that Cardano mainnet does, right? So we can simplify things and make our lives easier by, restricting those things. Similarly, we don't need governance rules. We don't need to reuse Cardano's governance stuff or staking, on the L2 ledger, because those are fundamentally L2 aspects, right? They don't really make sense to have in an L2 ledger, right? And lastly, we have these purple circles, right? So these are L2 transactions, but the cool thing about them is that they can indicate that some of their outputs should go not to the L2 ledger as new UTXOs, but instead should be withdrawn to the L1, right? So these L2 transactions, as we'll see in a moment, they look basically the same as the simple L2 transactions, but via some metadata tricks, we are able to indicate that, okay, these outputs, these particular outputs, should actually go out and be paid out on L1 instead of being added to the L2 ledger state. So this is how withdrawal works in Hydrozoa, right? And so overall, the L2 ledger, one of the tasks of L2 consensus is to determine what is the sequence of these events, right? So users are submitting these events to the peers are broadcasting them to the other peers, and then together the peers are collectively determining what is this timeline of events that all the peers can agree on, right? That's the essence of consensus. All right, so let's take a look in more detail what I was talking about before in terms of deposit UTXOs and how they get absorbed into the head, and then how we add corresponding UTXOs of the L2 ledger. So over here, I've drawn some deposit transactions, right? And I say, okay, I just have a bunch of deposit transactions. Each deposit transaction creates a single deposit UTXO, right? And each deposit UTXO has some set of, we call them genesis obligations. These are essentially like virtual outputs that we say that if this deposit is absorbed into the head via some settlement transaction at some point later on, then these genesis obligations will correspond to some of the new UTXOs that we'll add on the L2 ledger, right? So deposit transactions are essentially dictating these genesis obligations, and the genesis obligations are turned into actual new UTXOs on the L2 ledger, right? After the deposit UTXOs are absorbed by these settlement transactions, right? And this is quite nice because it means that, you can have, you don't actually need to recreate all these genesis obligations as actual UTXOs on L1, the way that Hydra does. So for example, with Hydra, when an incremental commit is made, right, you actually have to do it like one UTXO at a time, right? You can't just send in just the total sum of funds that you want to deposit into the L2, right? And then have separately a definition of how those funds should be allocated to different new UTXOs that you create on, in the L2 ledger, right? So with Hydrozoa, we do have that ability to do that, right? So the dual picture of what we had just discussed, right? So what we discussed in the previous slides was how funds come into the Hydrozoa head, right? Via these deposits and settlement transactions, and then via genesis events, right? The opposite of that is how funds come out of the head, right? And the way that works is you have transactions, right? I color this purple because it's not a simple L2 transaction, it's an L2 transaction with some withdrawals, right? So as usual, it spends some L2 UTXOs. It can reference some L2 UTXOs if it needs to, right? It produces some UTXOs which will stay on L2, and it produces some other outputs, which we call payout obligations, that should be withdrawn to L1 instead of being added to the L2 ledger, right? And so corresponding to this, on L1, we will have a settlement transaction, which based on these payout obligations will pay out UTXOs on L1, right? Corresponding to these outputs of the L2 transactions, right? And the way we distinguish these outputs from these outputs in the transaction is via metadata. So in the metadata of this transaction, we simply say that, all right, outputs number 3, 4, and 7 of this transaction should go to L1 instead of going to L2, right? And that's as easy as it is, right? So from a user perspective and from a tooling perspective, creating L2 transactions for Hydrozoa and supporting withdrawals is as easy as creating the same transactions that you know and love for regular Cardano, but simply adding some metadata, right? That indicates which of the outputs should go to L1, right? So we've tried really hard to make it, easy to reuse a lot of the functionality that already exists with Cardano's development tools and wallets and so on, right? So you don't need to do any weird stuff with this, right? So let's take a look at Hydrozoa's multi-sig consensus. So as you recall, this is where the peers together are deciding what is the timeline of events, right? And they are gathering signatures for these L1 transactions that that execute the absorption of deposits and the payout of withdrawals, essentially on L1, right? So the way we do this is via blocks, right? We have minor blocks, right? So these are blocks that contain only L2 transactions. So since the previous block, the only thing that has happened was there have been a bunch of simple L2 transactions submitted, and none of those L2 transactions withdrew anything to L1. This means that we only affected the L2 ledger state. We don't need to actually do anything on Cardano L1 at all, right? And so those L2 transactions can be packaged up into what we call a minor block, right? A major block is a block where we have at least one deposit that needs to be absorbed. We have a genesis event, right? Or we have one transaction, at least one transaction with an L1 bound output, which means we need to pay something out on L1, right? Or both, right? So some combination of these two. And this means that for a major block, we do need to actually interact with Cardano's L1 somehow, right? Via a settlement transaction, right? Finally, we have a final block. And this is triggered when we have a way for every peer can indicate that I want the next block to be final. And a final block is a block where we withdraw all funds that still remain on the L2, right? And we essentially the head will not exist after this sequence of transactions on L1, right? So this is a graceful way for us to essentially shut down the head, right? And again, this is all within the multi-sig regime, which means we are able to do this via one or more transactions that are all just simple multi-sign transactions with no clue to script interaction, right? And it's just the peers coming together and deciding collectively how they want to do this in a coordinated way, right? So correspondingly, the L1 effects corresponding to these L2 blocks, for a minor block, there are no L1 effects at all. For a major block, we have settlement transactions and rollout transactions, more on these in a bit, right? Plus we have fallback transactions also. I'll describe them in a bit, right? For final blocks, we have finalization transactions, rollout transactions, and DNet. And we don't have any post-dated L1 effects because after these transactions go through, there's nothing else to be done. We don't need a backup plan or anything because the head is essentially shut down after this, right? So then the consensus protocol needs to address the following questions. Who gets to propose the next block, i.e. the leader, the block leader? Which pending events does that peer need to include in that block? How do the peers verify the leader's proposed block? How do the peers indicate that they are confirming this block? And how can a peer gracefully terminate the protocol, i.e. trigger that finalization procedure, essentially, right? So for the first question, the answer is we do a leadership rotation. This is very similar to how Hydra does it, right? We just kind of go for, if Alice is the current leader, right? Bob is going to be the next leader, and then it's going to be Carol, Daniela, Aaron, and back to Alice, right? So we just rotate among them. Each leader is basically receiving all the events that are broadcast by the peers and assembling them into blocks. So within a block, you basically say, all right, based on the queue of pending L2 events that the leader has received, he's going to apply them in order of arrival. And then he's going to basically say, all right, this is valid, this is valid, this is invalid, this is valid, 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 invalid, valid, valid, right? And so he's basically partitioning this queue into the valid events and the invalid events, right? Corresponding to these check marks and X's over here. Similarly, he's receiving some L1 deposit requests, and based on the previously approved deposit request, some of them as they mature, we need to make a decision. Are we going to try to absorb them, or are we going to decide never to absorb them, right? Because they didn't exist, right? So the life cycle of a deposit is that you have a user creates a deposit transaction and a refund transaction and provides them to one of the peers via a request, right? And then that peer broadcasts it to all the other peers. And as part of the Hydrozoa consensus protocol, right, the block leader will then include that request, in the block, saying that, hey, okay, we're accepting or we're registering this deposit request, or we're rejecting it because something is wrong. There's some information that is incorrect in that deposit request. Therefore, we're rejecting it, right? And that sets up that deposit to be monitored by the head from then on, right? And when a certain amount of time passes, and we have sufficient confidence that this deposit UTXO has settled or should have been settled on L1, right? It's more or less immune from rollbacks, right? This is when we make a decision to absorb or to not absorb that deposit, right? And that decision is made based on whether that deposit UTXO exists, after that maturity period elapses or not, right? Because if it exists, then we know it's well settled and it's safe to absorb it. If it doesn't exist after all this time, then we know that, okay, it's probably never going to exist. And so we're going to decide to just never attempt to absorb this, right? And therefore just issue an immediate refund just in case it somehow shows up by the user and move on. Never think about this deposit again, right? So that's essentially, these are the contents of the block. So essentially the decisions on the L2 events, right? Which ones are valid and invalid, the decisions on which deposit requests or which deposits to register for monitoring, and then for the monitored and mature deposits, which ones we're absorbing and which ones are we kind of refunding or rejecting, essentially, right? And so the block leader, once he's put together this block, he's going to broadcast it to all the other peers, right? And every peer is going to essentially replay this block, right? So they're going to go through the list of valid L2 events, apply each one, and locally verify that they are indeed correct according to the ledger rules, right? And relative to the ledger state that we ended up with from the previous block, right? And then he's going to validate that the invalid events are invalid, right? So that the block leader didn't sneak in some of the valid events as, invalid events to ignore them somehow, right? So we're essentially checking the work of the block leader here. Then based on that, we can check the KZG VLS commitment is essentially a summary of the L2 state that we reach, i.e. like the active UTXOs that we have in the L2 ledger after we've applied all of these L2 transactions, right? And then we also check the block leader's work in terms of which deposit requests he's registered or rejected, and which deposits he's decided to absorb or refund, right? So, yeah. So that's in terms of like locally what each peer is doing. If he's a leader, then he's constructing a block. If he's a follower, then he's verifying the block in this way. How do the peers communicate to each other with this stuff, right? So I'll use the example of a major block because that's the most complicated one. So the leader broadcasts a new block, right? And then the followers are going to individually, each follower and the candidate, i.e. the next leader, they're going to check the block. And if they agree that this block is correct, right, then they're going to send back their signatures for the block header, or like the KZG BLS commitment that summarizes the L2 state reached by the block, and for the transactions, some of the transactions in this block, essentially all the L1 transactions except for settlement, right? So then once each peer has received all of these, then in the second round, they're going to broadcast their signatures for the settlement transaction. And the reason why we split this up into two phases is that we want to make sure that this is atomic, because essentially none of these effects can happen on L1 without the settlement transaction that kicks them off, which means that unless the settlement transaction is signed, right, the signatures for this don't take any effect. And by delaying the signature of the settlement transaction to a second phase, it means that we can make it all or nothing. Either all of these are signed or none of them essentially are signed, right? Because none of these can take effect before this is signed by everybody, right? So this is how we can guarantee atomicity, because otherwise you'd have this weird situation where maybe one of the peers maliciously signs a settlement transaction, and he's the last signature, so the settlement transaction can go through, and then only signs some of the rollout transactions, but not others. And that means that they would break, like not all of the rollout transactions would be executable. With this, we can guarantee that the entire package of L1 effects will be signed, right? So these this sort of two rounds signing is required for major blocks and for final blocks, but not for minor blocks. For minor blocks, which are probably going to be a lot more frequent than major blocks and final blocks, because it's just simple L2 transactions, and the whole point of a state channel is just to do a bunch of stuff on L2 without necessarily touching L1. For those, you only need one round. Because the only thing you're signing really is just the KZG BLS commitment that says this is the L2 state that we've reached as a result of all these simple L2 transactions, right? So yeah, so that's basically how consensus on Hydrozoa works, right? Now let's talk a little bit more about these transactions, like L1 effects. So initialization looks like this. We have some funding UTXOs, right? And we're going to grab all the funds from this, and we're going to put it into the Treasury UTXO, right? Or actually, I should say, we have arbitrary UTXOs in here. We don't really care about the inputs. The only thing that we care about in the initialization transaction is these two outputs. We care that there's a Treasury UTXO created with a minted Treasury token that gets put into here that uniquely identifies this head. And we have a multi-sig regime UTXO created, right? That contains, some deposits to make sure that we can always go to the rule-based regime, right? The rest of the transaction can be arbitrary. So this gives a lot of freedom for people that want to adopt Hydrozoa, because it means that the way that you initialize the Hydrozoa head gives you a lot of freedom, because the only thing that the Hydrozoa cares about is that you contain these outputs in the transaction, right? And that you identify one of your inputs as the nonce that kind of gives this head its identity, and everything else is completely up to you. So you have complete freedom to do whatever other things you want to within this transaction, right? And we think this is a pretty cool feature that we'll be leveraging a lot in the coming year with the various use cases and patterns that we'll be using, right? So additionally, with this initialization transaction, or as part of the initial configuration for the head is initialized with some initial L2 ledger state, right? So this is some number of UTXOs that we populate the L2 ledger with, right? And all of them must be funded by the funds contained in the treasury, right? Because the head needs to remain solvent, right? If we have more value in the L2 ledger than we actually contain in the treasury, it means that we're insolvent. We aren't able to withdraw all that value on L1, right? So one of the constraints that we check, during initialization is that this treasury UTXO contains sufficient funds for all of the UTXOs that we added to the L2 ledger, right? That way we remain solvent. The next transaction type that we mentioned was the settlement transaction. So what it does is it spends the old treasury, it produces the new treasury, it spends some deposit UTXOs and puts all their funds into the treasury, right? And it pays out some payouts, like some payouts based on the withdrawals from L2 transactions, right? Optionally, it can create a rollup UTXO, right? And this is how we are able to essentially remove the restriction that usually exists on Cardano, where you're limited in the number of outputs that a transaction can have, right? Which is inconvenient for a head because potentially, you want to be able to on the L2 ledger to freely withdraw UTXOs and not worry about, can these UTXOs fit into a settlement transaction or not? So the way we do this is that based on those payout obligations that are generated by the L2 withdrawals, we're going to pay out as many UTXOs as we can in the settlement transaction, and then we're going to put the rest of the funds that need to be paid out in aggregate into this rollup UTXO. And this rollup UTXO can be picked up by a subsequent transaction, which will pay out more of the withdrawn UTXOs that we need to pay out, and then put the remainder in another rollout UTXO, which can be spent in another rollout transaction, and so on. Right, so you basically get this chain of rollout transactions that allow you to pay out more UTXOs than what you could otherwise fit in the settlement transaction. So does that make sense? See some thumbs up. All right, cool. Right, and then the last transaction that I'll discuss today, we have more, but I'm just conscious of the time, is the fallback transaction. So this is how we go from the multi-sig regime to the rule-based regime. So in this transaction, we are going to spend the treasury UTXO from the head's native script, i.e. the multi-sig regime, and we're going to put it into the into the rule-based regime. So we're going to put it under the Plutus script, right, corresponding to the rules that we want to impose on the treasury in this regime, right? And additionally, we're going to spawn some UTXOs for dispute resolution. The long story short of this is that every peer is going to get one chance to indicate what they believe to be was the last thing that we all agreed on in the multi-sig regime, right? And then we're going to tally up all of these votes, right? Pick the latest one among them, and basically that's going to be the state based on which we are going to allow the peers to start withdrawing their funds from the head without needing multi-signatures anymore, right? Because they could just show proof, cryptographic proofs of that LT state, right? So in building all these transactions, we've leveraged the Scala's framework, right? So this is a Scala-based framework for on-chain code, for off-chain code, for ledger rules, and a bunch of other things. So, we've been quite fortunate to have a great collaboration with the Scala teams. In particular, the transaction builder, at least the advanced one that we're using in Hydrozoa, we actually contributed upstream to Scalus. So it's been kind of a back and forth kind of collaboration here. And what this allows us to do is to build transactions in a transaction builder that can keep track of the signatures that are needed, can keep track of the resolved inputs, and gives you more kind of more convenience in terms of redeemers. Because oftentimes when you add a redeemer, you might invalidate certain indices, and it just gets very complicated. Whereas in this transaction builder, all the indices are determined at the end, so you don't need to worry about sort of changing them and stuff. You can just worry about adding your inputs, adding your redeemers, adding your outputs, whatever, right? As a sequence of these basically steps with which you're modifying the transaction context. And at the very end, you derive the resulting transaction out of this. So this is a more flexible framework that we've used to build our, frankly, quite sophisticated sequences of transactions, as you'll see in a second. So if we connect the transactions that I talked about together. So far I've been talking about them individually, right? But of course, you can see here, this settlement transaction is spending this blue treasury, absorbing some of these deposits, creating a rollout UTXO, right? And so this connects to this rollout transaction, which connects to this rollout transaction, which connects to this rollout transaction. And furthermore, from the settlement, we have another treasury, which connects to this entire sequence of settlement and rollout transactions as well. So essentially, what we have is a tree of transactions, right, that are being generated by the head continuously, right? And so, for example, what you're looking at here could be the life cycle of a head that stays in the multi-sig regime for, let's say, its entire life cycle, right? So we have an initialization transaction followed by the first settlement transaction and some rollouts that pay out some funds, right? And then we have another settlement transaction and another chain of rollouts, another settlement transaction, another chain of rollouts, another settlement transaction, another chain of rollouts, right? Settlement transaction rollouts, finalization with some potential rollouts, and then deinitialization that just, essentially burn some of the head tokens and stuff, like the tokens that we're using to identify the treasury UTXO and the multi-sig regime UTXO and stuff like that. We're going to burn them in the initialization transaction, and we're going to basically distribute the remaining funds to the peers, right? So yeah. And from the initialization transaction and from each settlement transaction, we also have these fallbacks, right? So this, in a nutshell, is the entire tree of L1 transactions that we need to worry about, or not worry about, that we need to basically submit as a consequence of us confirming blocks for Hydrozoa, right? These are the L2 effects, the L1 effects that need to take place on Cardano. And we can use a simple numbering scheme to easily traverse this tree, right? So you can see that it has this spine here, right? And whenever we move along the spine, we're going to increment the first number, right? You could think of this as essentially the major version, right? And then we have these like ribs growing out of each each node in the spine, I guess, right? And these are the rollout transactions. And we can number them with the second number in the pair, right? And what this allows us to do is, at any given moment in time, we can query the L1. So for example, our L1 could be Cardano mainnet that we're querying via BlockFrost. And BlockFrost is going to tell us that, okay, the current treasury UTXO that sits at the multi-sig address is the one, there's some treasury UTXO sitting at the multi-sig address. And there are some rollout UTXOs also sitting at the multi-sig address, right? And so based on that, we can say, all right, well, that treasury UTXO that BlockFrost told us exists right now in Cardano mainnet is the one that we need to spend as part of this settlement transaction. So it means that this entire tree of transactions has not yet been executed on Cardano L1. So we need to resubmit these to drive the system to our desired target state, right? Similarly, if BlockFrost tells us that, hey, there's a rollout UTXO that currently exists, at the native script address, right? And we know that that's the rollout UTXO that needs to be spent by this rollout transaction, then it means that we need to resubmit this entire sequence of rollout transactions, right? And similarly, if there's another rollout UTXO that exists, right, and it corresponds to the input of this rollout transaction, then we know that we need to submit both of these rollout transactions. So this is how Hydrozoa is able to be essentially resistant to rollbacks, right? Because we're just periodically polling Cardano L1. It tells us what the current UTXOs are, and based on those, we know that we have these deterministic transactions essentially that need to spend those UTXOs. So we always know how to drive the system to our target state. Our target state being essentially the state that you would reach if you had evaluated all the transactions in this tree that we have constructed so far, right? And this means that we don't need to ever really wait for confirmations of anything on Cardano L1, because we know this entire sequence of deterministic transactions that we have so far, right? And we just have a dedicated process that's going to just drive Cardano forward, right? And resubmit whatever is needed, resubmit it until it reaches that target state, right? And until that target state becomes like immutable on Cardano L1, right? So we never need to wait for anything. We can just send these transactions and then not worry about the response, and then check in again, let's say 20 seconds, 30 seconds from now, to see if we need to resubmit something again or if we're already at the target state. So we have a dedicated process, we call it the Cardano liaison, which interacts with Cardano in this way, based on the L1 effects that we've generated as part of our consensus, right? And then the other thing that Cardano liaison does is it always checks whether one of these fallback transactions, all of these fallback transactions, I should have mentioned, they're post-dated, right? So the idea there that if consensus breaks down and we are no longer able to multi-sign new settlement transactions or fallback transactions or just new blocks in general, we need to transition to the multi-sig regime without signing anything new. And this is why we sign these post-dated fallback transactions. So I should have mentioned back here, this is a post-dated transaction, right? And it will become valid sometime in the future, right? If we don't have any other settlement transaction that's going to spend the treasury input that the fallback transaction tries to spend. So essentially, every settlement transaction is in competition with some fallback transaction. And if it takes too long to create that new settlement transaction, our L2 consensus is stalled, then it means that our fallback transaction is what we need to follow to get to the rule-based regime and allow the peers to recover their funds, right? So this is why you can see in the skeleton, right, from the initialization transaction, you have the initial fallback transaction, right? And if we take too long to generate this settlement transaction, right, presumably our consensus has failed because, 2 days have elapsed and we have not been able to come up with a new major block that spends the treasury, right? It means that this fallback transaction becomes valid, right? So Mathieu asks, does L1 rollback complicate the fallback transactions? No, it doesn't. because the settlement transactions, they. Oh, so you mean like, is there indeterminism between whether we're in the rule-based regime or we're still in the multi-sig regime based on rollback of the fallback transaction? Yeah, that's one of those things that we're kind of handling, but I think it's fine because we can basically keep the Cardano liaison running for the multi-sig regime, and it's going to attempt to resubmit the settlement transactions, and we can spawn the rule-based regime processes that are going to try to interact with the rule-based regime. And if fallback tells us that, hey, forget all the stuff that happened in the rule-based regime, we actually ended up successfully staying in the multi-sig regime, then I mean that's only better, right? And we can keep going with that. So our plan for that, or like the way we're implementing it right now, is to kind of if we're reaching a situation where we need to spawn the multi-sig regime handlers or like processes, we'll just spawn them kind of in parallel, and they'll pursue the parallel reality where the fallback transaction is assumed to have finalized, right? While at the same time we keep the multi-sig regime one processes active, right? And specifically the Cardano liaison, and it's just going to try to pursue, submitting all of the existing like settlement transactions stuff that maybe follow that fallback, right? But we're not going to allow. So Mattia asks, do the old rollup transactions need the multi-signatures too? Well, the thing is, these rollout transactions, they have nothing to do with the treasury anymore, right? So they're deterministic. If this settlement transaction has been executed, right, then its rollout UTXO just exists. And deterministically, all of these rollout transactions can be submitted no matter what. They don't even have an expiration time. They don't depend on consensus anymore. Anybody can submit these rollout transactions, regardless of whether after this settlement transaction, if we go to the fallback regime, then all of these guys obviously are no longer submittable, so long as this doesn't get rolled back. But all of this stuff is still submittable, right? So that's the way this works. So the rollout transactions are kind of guaranteed as long as their corresponding settlement is finalized, right? Fallback only invalidates the settlement that follows it, right? And all of its descendants. So yeah. So this looks, admittedly, this is a pretty complex scheme, but the freedom it allows us is to be able to confirm things on L2 without ever really waiting for L1 confirmation times. So this means that the Hydrozoa head can remain pretty lively, right? Because we can confirm L2 withdrawals. We know that they're going to be somehow processed via settlement or rollout transactions. We know that those are going to be submitted, right? And we can just keep going. We can just keep confirming stuff on L2 without waiting. Similarly, for deposits, while we do need to wait for the actual deposit UTXO to mature on L1, we can just keep going with our L2 consensus. And we know that eventually, once that deposit matures, we'll just do like the leader will do a quick check to see whether that deposit UTXO exists at the time of maturity, right? And if it does exist, we'll absorb it into the head in some settlement transaction. And we don't need to wait for that settlement transaction to go through. We could just proceed further with L2 consensus and just add those UTXOs and allow them to be spendable on L2, right? So we never need to wait. In fact, we don't even necessarily need to wait for an initialization transaction either, right? So I could think of a use case where, let's say you have some conglomerate and they want to spin up a Hydrozoa head, right? And there's a fairly high level of trust between them. So they know that none of them are really going to be messing with the initialization transaction, right? Then they may be comfortable proceeding to start submitting stuff to the L2, like submitting L2 transactions without waiting for this initialization transaction to, fully settle on L1, right? So even less waiting, right? And similarly, the way we handle our deposit transactions, I think I forgot to draw it on the diagram, but the point is that, every deposit transaction refers to the multi-sig regime UTXO. And this UTXO exists for the entire duration of the multi-sig regime, which means that if the initialization transaction gets rolled back, then just naturally all the deposit transactions also get rolled back. And so you don't even need to worry about having to refund them or anything because they just naturally get rolled back, right? And if it gets rolled forward, right, then naturally all the deposits can also get rolled forward, right? So in this way, you never have this situation where you need to wait for the initialization transaction to be confirmed before you even attempt to make new deposits or anything, right? You can just keep moving forward. And I think this is a huge advantage because like the main promise, like the main reason why we're doing state channels in the first place is to reduce latency, reduce the waiting time, right? And to make potentially make your interactions with L1 more efficient by combining your interactions into these like more packed settlement and rollout transactions. So yeah. I think that's where I'll end it today. Of course, there's a lot more that we can talk about in Hydrozoa, and I think we'll have more future sessions in the CF Dev office hours. But for today, I think this is enough. So I'll open up the floor to questions. Darlisa, how much time do you think we have? Is it just the 5 minutes left in the hour, or do people want to stay on for a little bit longer?
Well, if people want to stay over, that's fine. I think you can stay another maybe 5 or 10 minutes for other questions. The content was very, very interesting. I think people here probably has more questions. I think starting with one from Matthew. He's asking if is there an interest in using Hydrozoa if there is only one leader or something even more lightweight would make more sense.
Like one peer head.
Yeah.
Oh, yeah, that's an interesting case. That's actually something that I thought about way back at the beginning, because the degenerate case, right, where you just have one peer, is actually it's like a multi-sig. It's like a wallet on steroids, right? Because you can essentially have an L2 ledger, your virtual ledger, and you can just submit your transactions there, like as many as you want, whatever, and then you can have them be compressed into the settlement transactions of L1 that execute all of the effects of those L2 transactions, right? And so it can be a way for you to basically do a bunch of things and treat them as individual transactions in your virtual ledger. But then you know that on L1, it's going to be the most efficient possible compact form because we're going to try to compress all of these into the smallest number of settlement and rollout transactions.
Yeah,
so
I had this question actually because I had a use case in mind. So I'm part of a sports association, and we have an event that we organize annually, and there is some treasury to be managed, right? And there is food to sell that is sold all the day. And usually what they do is like, it's a very restricted environment where you basically know everyone who is there. They have been registered and everything. And people can buy food. And for example, when they buy food, either they pay with card or sometimes they just pay a ticket of like 10 tickets, right? And they give one ticket or they tick something on the card for every time you spend something. I was wondering if it could be interesting to have something based on a Hydrozoa head that instead of giving paper tickets to people, maybe I give NFC cards to people and I can scan the NFC cards and adjust the balance depending on what they pay, something like that. So I was wondering that kind of use case was useful, but there is only one peer, right, doing the transaction. So
yeah, absolutely. So I've had this use case in mind for a while now. We haven't quite developed, like our current implementation is not quite targeting it yet because, well, essentially in order to do this, you could just reuse the existing stuff and you could just have a consensus of one. It's just that there's a bunch of redundant stuff that's going on in our consensus and messages being theoretically sent back and forth that kind of doesn't really need to happen if you only have one peer, right? So it's essentially you would take Hydrozoa and somehow deactivate some of the modular components of it that you don't need when there's just one peer, right? But yeah, for sure, that could be possible. On the other hand, what I would suggest is that maybe even in that use case, it might still make sense to have multiple peers more for kind of security purposes, because it means that since it's unanimous consensus, you need to hack both peers, for example, or all three peers, right? So it can be like several computers, right, that are all replicating the same computation, right? It's the same distributed ledger, but this gives you extra redundancy security-wise, so that if one of the servers gets hacked, you don't get owned, right? All three need to be hacked, and you could potentially have them be operated. So it's a little bit more overhead in terms of like computation or like cloud costs or something, right? But in some use cases, it might be worthwhile to do because maybe your treasury is big enough that you actually do want that redundancy. You do want that multi-sig kind of to back you up, right? But in a simpler case, if it's just like, there's not a lot of funds at stake, right? Then it should be perfectly fine to just run a single peer head, so to speak. And in that case, you would kind of deactivate a lot of the peer-to-peer communication stuff and a lot of the stuff that you don't really need from Hydrozoa, right? And you just focus on running the virtual ledger within your peer, generating the L1 effects that I described, right? And then just signing them with the peer, and basically reusing the same, signature mechanism that we already have, right? And just only requiring that one signature, right?
And how much connectivity do you need for using it? Because, for example, you mentioned that everything is deterministic, right? You can try to replay the transactions. So do you need connection to the network, like when you set up the heads and then when you close the head? But do you need connection in between, like?
Oh, are you talking about connectivity to Cardano?
Yeah.
Actually, if it's a single peer, you don't really need a lot of connectivity, right? Because the way Cardano liaison works is just it periodically pulls, right? And in fact, you don't even really need to pull that often, especially if you're the only peer, right? Like in fact, you don't even really need to worry about fallback if you have a single peer, because you're the only signature holder. You can use your own single key to do whatever you want with the funds, right?
Mm-hmm.
Like if you can't really end up in a situation where you aren't capable of gathering the multi-signature for something, right? Because it's just a single signature, and as long as you don't lose your key, you don't really need a fallback regime. So theoretically, a single peer Hydrozoa head can be guaranteed to stay in that optimistic regime, the multi-sig regime, essentially, right? And in that case, it doesn't even really need to have connectivity to any other peers, right? So you don't need to have continuous internet access, and your access to Cardano can also be fairly, sporadic, because like the Hydrozoa protocol essentially ensures that discipline for yourself, that you're not going to contradict your own transactions, right? And so you know that they're going to be deterministically submittable whenever you get, you regain connection to Cardano. Right.
That can be very useful for events where you are like in the woods or in places where you don't have connectivity, but you still want to have a ledger shared between people participating in.
Yeah, and I'd definitely like to pursue that use case a little further if we get the chance, right? For now, we're kind of creating like the basic kind of general framework for Hydrozoa, but going down sort of the one head, the one peer degenerate head path is very interesting to me too. So Michelle asks, it sounds like the number of heads will be set when the L2 instance is created. I think you mean the number of peers, right? Yes, when you initialize a head, you set what the peers are, right? But one of the things that one of the features we're committed to for the Hydrozoa MVP, right? We haven't quite gotten into it yet because we're still putting the pieces together for some of the other features, right? But one thing that we do want to do is we want to allow the peers to modify the number of participants, right? So essentially, you can think of it like this: if all the existing peers agree, right, you have a unanimous multi-sig from all of them, then you can say that, okay, this peer we allow him to leave, this peer we allow him to enter, right, and this peer we allow him to change his key. So he's still here, but he's just going to use a different key, like for key rotation purposes or something, right? So this is what we want to have in the Hydrozoa MVP, right? And it can be as simple as essentially a multi-sig transaction that spends the treasury from the old native script address and sends it to a new one, right? Because the new one, is controlled by the new set of keys, right? That's essentially what needs to happen. So yeah, for sure. Second question that Michelle had, can observers join the network like an explorer or a data provider like Brockfast? Absolutely, right? So the way that our peer-to-peer consensus works, and I didn't get a chance to get into this too deeply this time, maybe I'll talk about it a little bit next time, is that essentially for the ledger events, so recall the ledger events are either deposit requests, so this is a request for a deposit to be monitored and potentially absorbed when it matures, right? Plus the other event is an L2 transaction, right? Which, as I mentioned, spends some L2 UTXOs, produces some L2 UTXOs, and can also output some payout obligations that will be paid out on L1, right? So those are the ledger events: register deposit and LP transaction. These are broadcast. So like if each peer is the originator of each one of these ledger events, right? So Alice, for example, might have originated this register deposit request and these several LP transactions. Bob might have originated these other ones, and they're broadcasting it to everybody else. And the way that we index things in Hydrozoa is every ledger event is identified not by some weird transaction hash or something, but really just by the peer that originated it, plus the sequence that that event has within all of the events that that peer has broadcast to everybody, right? So you could have Alice's first event that she broadcast to everyone was, let's say, a register deposit request. Her second event was LP transaction. Third event was LP transaction. For Bob, he had some other LP transactions, some other LP transactions. So essentially, every peer is broadcasting events to all the other peers, and the way we identify every event is by which peer broadcasted and what the sequence of that event was within that peer. And the way that our consensus sort of catches up on all these events is it says every block mentions that if you've caught up to these indices for these peers, then you have all the information that you need to verify this block, right? So you basically were saying, okay, block number 3, in order to verify, you need to have seen the 5th event from Alice, the 7th event from Bob, and the 3rd event from Charlie, right? And if you've caught up to those, then you have all the information you need for this block, right? And so this method, of just having the events be sequential, makes it very easy to catch up on all the activity of the head, because you can basically query every peer to catch you up on all of the events that it is received from all the other peers. So every peer can act as a backend for you in terms of catching up on all these events, and then you can just index them, right? This also makes it very easy to keep track of the life cycle of things, because we know that when block number 3's settlement transaction is immutable on Cardano, we can essentially forget this information because it's no longer needed. It's no longer needed to resolve any disputes, right? So we have a very good data retention policy potentially in Hydrozoa, where we can just keep track of the last, up to the immutable period, all of those blocks, right? And everything else, theoretically, you could forget. Or if it's important to keep track of this information, you can just archive it in some separate node somewhere, right? And that could just be an explorer of all this activity in the head. Plus, this approach also allows us to do time travel queries potentially. So you could basically say that, hey, I want to do a query based on the UTXO set that existed at the time of this block. So right now, our latest block was number 10. But I want to do a query that was as of block number 7. So it's like a time traveling query, which actually is much more convenient, I think, than what you currently can do with BlockFrost, because BlockFrost, for example, will only tell you what currently exists. And sometimes it's inconvenient because you might need to send several queries individually and then piece together their results. And you're hoping for a consistent picture, right? Like you're hoping for, like a single slice of history, right? Not, things that are spread across the timeline that may contradict each other because they've been sampled at different points in time. Whereas with Hydrozoa, one of the explorers that we want to create as part of our Fund 14 projects is one that enables you to pin down the point in time when you want to do the query as of a particular block, let's say, right? And then submit a bunch of individual queries separately, right? And have them all see a consistent view. A consistent view of the ledger at that point in time, right? Even historically. Another question from Michelle was, do you have any wallets that can work with your L2 yet? Well, the way that we have done this is that, kind of all of them can work with us, right? Because our L2 transactions are just regular transactions, right? With just some additional metadata attached to the transaction. So it's not so much the wallets that need to change to be able to work with Hydrozoa. It's more the just the transaction builders that need to slightly, or just have a slight additional tooling to set that metadata properly, and then the wallets will be able to work with it. Maybe the wallet interface would need to evolve to properly display when which of your transaction outputs are staying at L2 and which ones are going to L1. Plus, maybe for transaction submission, right, you'll need to know how to submit to a particular head, right? Whereas wallets currently only know how to submit to Cardano mainnet or particular public testnets. So yes, that will still need to be done. But in general, just in terms of signing transactions, it's the same as usual. There's nothing fancy there, and wallets should be able to parse these transactions no problem, right? And most opt-in libraries should be able to build these transactions also no problem. So we don't really see that as a big obstacle to adoption. How does one create Hydrozoa transactions? So as I said, these are just regular transactions, right? So if you want to create an L2 transaction, you create an L2 transaction just as usual, and you can just indicate in the metadata which of those outputs need to go to L1. If you're talking about how do you create a deposit transaction, then it's literally, it's just a transaction that creates a UTXO that has a particular datum structure that we're expecting in Hydrozoa, and that gets sent to the Hydrozoa head's native script address. Plus, there's a refund transaction that needs to spend that UTXO and send it back to you, essentially, according to the refund instructions that you've encoded in the datum of the deposit UTXO, right? And we're planning to develop some SDKs and stuff, some simple SDKs that will kind of handle that for some of the major off-chain libraries, maybe. And so it should be fairly easy to construct deposit transactions. Other than that, what else do we have? Initialization transactions, similarly, we'll have an SDK to build some basic ones, but there's a lot of flexibility there. So really, it'll be up to adopters to make full use of that flexibility to really, work as well as they can make it work with their use case, right? So there's a lot of freedom there in terms of how you can do initialization transaction, but we'll provide an SDK that will just allow you to create a very basic, simple initialization transaction if you don't care about that customization potential, right? So yeah. Do Hydrozoa transactions have zero fees? I'm guessing this is about the L2 ledger. Yeah. You can set the protocol parameters such that everything is zero fees on L2, right? Or you can set them to collect fees on L2. Really, it's kind of up to you, right? Hydrozoa, is it intended to be a short-lived instance, or can it also be infinitely long-lived? Well, the philosophy here is hope for the best, plan for the worst, right? So if you want, a Hydrozoa head can operate indefinitely, and you can just continuously work with the L2 ledger, spend UTXOs, produce UTXOs on the L2, bring UTXOs, bring funds in from L1, withdraw funds out to L1, right, and just continuously operate it this way. But at some point, there's a probability that your consensus will break down because one of the peers becomes responsive for too long. And by the way, when I say responsive for too long, I mean on the order of not responding for 2 days, right? That's a problem. Right? At that point, you need to be able to go to the multi-sig regime, and you need to be able to recover your funds because otherwise it's a problem, right? So that's why the rule-based regime exists. But if you want to stay in the multi-sig regime and you're happy to stay connected to all your peers indefinitely, then sure, they can run indefinitely. Yeah. Last question. From my point of view, what are the top 3 use cases where someone will want to go for Hydrozoa over Hydra or other L2s? So I would say the main advantage, or one of the main advantages of Hydrozoa is that it's a lot easier and more streamlined to bring funds in and out of the Hydrozoa head, right? So, and our L1 transactions are much cheaper, right? For the same amount of activity going on in terms of funds coming in, funds coming out. So for example, you can initialize a head with a single transaction, right? And that transaction, you're just putting the sum of funds that you wanted to put into the head, you're just putting all of them into the treasury UTXO, and then you are initializing the head with any arbitrary amount of UTXOs on L2, right? That just distribute the funds of the treasury among those L2 UTXOs. Similarly, our deposit transactions, every deposit transaction only needs to create a single UTXO that goes to a particular head, and that UTXO corresponds to some set of virtual outputs that will be created on L2 as a result of that deposit transaction. So again, you don't need multiple deposit transactions, one deposit transaction or something for every UTXO that you want to create on L2. You could just do it with one and create all the L2 UTXOs that you wanted right away, right? With withdrawal, same thing. You can withdraw as many as you want from L2, and then Hydrozoa will compress them into the smallest number of L2, so L1 transactions that will pay them out on L1 with the cheapest fees. So for example, I think a settlement transaction with like 4 payouts and I don't know, 2 deposits or something costs like 0.18 ADA, which is basically the same as like, the 0.17 that you would pay if you were to pay someone from your personal wallet, right? So it's the costs are very marginal there, right? So in general, I would say any place where you need to really have a lot of flexibility and frequently need to bring funds in and out of the head, that's a great use case for Hydrozoa over Hydra, because with Hydra right now, it's a little bit painful to bring funds in and out. Even though they have incremental commits and decommits, it's not quite as flexible or cheap or easy, right? So yeah. More questions. When Hydro token? We don't plan to have a token. So we're just, we're developers. We're not marketers or anything. So yeah. HydrozoaPOS.com. You just registered? That's funny. Okay. Yeah, I think once we're done with the MVP, we'll start marketing ourselves a little bit more. We've kind of been running in ghost mode so far because the focus is a bit on the tech. But once we have like a solid baseline for which to kind of work from, and when it makes sense for people to start adopting, that's when we'll start having websites and marketing materials and more documentation and tutorials and examples and all that great stuff. What are the current theoretical TPS? Does the number of heads, number of peers slow DPS down, or doesn't impact it at all? The theoretical TPS is the same as Hydra because it's essentially the same thing, maybe slightly higher, maybe slightly lower. We're going to be benchmarking this in more detail in the coming months as part of our key projects. So we'll have more definite answers for this to you. But in principle, it should be similar TPS to Hydra in terms of the L2 transactions. Can L2 users also mint assets on the L2? Not yet, but that's a research program for our Fund 14 projects, which will be kicking off in January. Can minted assets be decommitted on L1? That's part of the same research program. It's a tricky question because not all L1 minting policies allow you to actually mint, like give you authorization to mint things, as a group of peers. Some of them have more complicated conditions. And so those definitely can't be minted on demand to be decommitted to L1, right? But if those tokens exist at initialization, like you've deposited them into the head essentially, or you deposited them via a deposit, then yeah, no problem. Of course you can withdraw them, right? So yeah. And then the last question, Darlisa asked, what is the timeline for MVP? We're hoping to complete it by mid to late January, right? So at that point, we'll be starting a lot of our kind of early adoption kind of conversations with various people, and we'll probably be presenting more demos and things like that for Hydrozoa. So
that's
yeah, look for that.
Yeah, and looking forward to that. Actually, probably by that time, there will be loads of people who would be looking to try it out. So talking about it, what would be the best way to reach out to you guys?
You can reach out to me on Twitter or Discord. My username is the same in both. It's Swiftly Unmoving, at Swiftly Unmoving. So yeah, if you want to reach out, then DM me on Twitter or on Discord, and I'm happy to respond.
Awesome. So I appreciate that people there might have other questions. So now the contact. Oh yeah, if you can put on this on the chat, would be helpful. So I would like to thank you, the Hydrozoa team. That was an amazing presentation, George. Thank you very much. I think that was very clear. The discussion was also even more interesting. So everyone was able to clarify the doubts. So thank you very much for that. And I look forward to have you again next year. Yeah, looking forward to come to these office hours more often. Yeah, thank you so much, you guys. So thank you very much, and have a great weekend. See you then next office hours, everyone. Bye-bye and take care. Okay, bye.